Hi folks, good morning. My name is Shailesh Manjrekar. I head AI here at Wikaio, and I'll be talking today about performance at scale for model training. To give you a little sense of the Flash market and AI/ML applications, so AI/ML applications are today the fastest growing applications in the data center, and they tend to leverage advances with 3D crosspoint, with computational storage, QLC flash technology, and several other new technologies in addition to the rapid progress done by the 3D NAND flash market. Because this market is primarily driven by low latency and high throughput applications. The flash and SSD market is estimated to grow to almost 90 billion by 2022. So it's a fairly big market. And the underlying infrastructure, whether it be cloud data center or enterprise data center, they need to be optimized for the kind of the workflows or pipelines what AI ML applications use for either model training or whether to analyze petabyte scale data sets while satisfying the critical cost constraints. So if you look at this market, most of the growth is driven by software defined storage. So on the right hand side, you'd see a survey we conducted with the ESG group, the enterprise strategy group, and you'd see almost 55% of enterprises today are leveraging software defined storage. 14% are aspiring to go there, and that's primarily because of the flexibility software defined products provide, the agility they bring to the table, and Weka is of course a big part of it. So Weka, on a high level, we are essentially a parallel file system designed grounds up for NVMe parallel flash. And what we do is we provide a simplicity like an NAS device or a NAS storage system. We provide and we expose an POSIX interface. So the look and feel is like a local flash file system. We leverage technologies like NVMe or Fabrics to provide highest performance speed at lowest latency. So we are the highest performing vendor today for either for spec SFS for IO 500 or STAC, stands for Securities Trading Council. And while we do this, we provide the scale which is relevant for this kind of new application. So we can support billions of files in a single directory and trillions of files across the namespace. Very important capability when it comes to AI/ML applications. So a little bit about the company itself. We are an AWS advanced technology partner, 600% growth last year. And we have 7 of the top 50 Fortune 50 companies as customers today. Several partnerships, strategic partnerships across vendors like Hitachi Vantara, Hewlett Packard, Lenovo, NVIDIA. Several of them are investors as well as strategic partners. So this presentation, I'll be primarily dividing into 3 parts. We'll talk about how this AI/ML applications are inherently different than the traditional file-based applications. Next, we'll talk about, as a result of this, how the underlying architectures are changing to be able to cater to those new requirements. And then finally talk about how Weka is basically presenting solutions to be able to cater to this new applications. And as data is becoming your new source code, how are you able to leverage data to provide actionable intelligence, to operationalize data sets, and also to be able to provide governance to these data sets. So let's dwell into the first part. So where do we see this kind of applications? So the traditional markets, whether it be high performance computing, high performance data analytics, or AI/ML, they are now getting penetrated with GPU computing, either using GPUs, or it could be using FPGAs, or they could be using AI accelerators. But there is a heavy influx of what we call accelerated computing, either using GPUs, FPGAs, or AI accelerator across these use cases. As far as Veka goes, we claim we power mobility as a service stack. So we have customers all the way from sensor manufacturers or to connected car or in-car intelligence, all the way up to services, which is WeRide as a company. So these are some of the several marquee customers what we have, whether it be Cerence, whether it be Too Simple, which is an electric truck company, autonomous truck company. Cerence is an in-car intelligence company. WeRide is a services company, and Innoviz is an LiDAR manufacturer. So talking about autonomous vehicles, safety is really a non-compromisable primary objective. You need tons of data to be able to train these models, which need to be extremely accurate. Okay, and you need to have a mechanism to be able to reproduce the experiments, because for the most part, the deep neural networks are like a black box. So the only way you can find out why an autonomous vehicle turned left when it was supposed to turn right is by keeping a tab on the data which was used for training that particular model. So this is an example of what we call a software-defined CI/CD pipeline for a software-defined car. So you have several of these survey cars running on the street collecting data, and this can range to the extent of several petabytes, at least a couple petabytes per survey car per year. All of this data gets ingested at the edge, what we call edge aggregation, and then there can be some form of ETL processing. Then it gets uploaded to the core, which is mostly where training happens, and then you can leverage the cloud, which can be used for economies of scale. And then on the top, you see large compute environments with several GPUs, all orchestrated by Kubernetes. And somewhere you have data being ingested, somewhere you have data being labeled, you have model training happening, somewhere you're doing simulation, which is also popularly known as hardware in loop or software in loop testing. So this is how a typical ADAS data pipeline would look like. The other thing which is happening with this particular applications is use cases are now moving from computer vision to more around conversational AI or NLP, NLU, what we call natural language processing, natural language understanding, and they're also becoming more multimodal. And the same thing is happening with advances in deep learning. So you have deep learning, your transfer learning, your federated learning, active learning. And this neural nets itself, they're becoming fairly complex with, with the likes of BERT and Megatron are now becoming very popular for NLP. And what that means is that there are several billion hyperparameters which each of these neural net models comprise of. And that makes the training extremely complex, and it becomes time consuming and extremely expensive as well. Again, labeling of this data set becomes very important, and a lot of these companies use a technique called semantic segmentation for labeling of that data set. We did a paper with Hewlett Packard, our partner, and this particular paper shows advantages of Weka versus an NFS-based solution. So you can see almost it took 15.85 milliseconds to be able to train or do semantic segmentation, whereas with Weka, we were able to bring that down by almost 7.4x in terms of latency. And that directly resulted into almost saving 4.5 days for 100 survey cars. Okay, so it directly kind of attributes to the top line and bottom line when you're doing semantic segmentation labeling for ground truth. That brings me to my second part, which is really about, as a result of these new applications, the underlying infrastructures are changing. So with GPU computing, what has happened is your compute layer has become extremely densified with, for example, a Tesla B100 GPU from NVIDIA. You are now looking at 5,000 plus cores, and that kind of parallelism needs different kind of storage stacks. So the traditional storage stacks just cannot keep those GPU cores busy. and better utilize that, right? And that's the reason why you need a storage stack which has that kind of parallelism built in into it. If you look at a traditional AI ML pipeline, somewhere you're doing massive ingest, somewhere you're doing labeling, somewhere you're doing neural net training, somewhere you're doing validation, somewhere you're doing inference, which is all about low latency, and somewhere you're doing life cycle management. So as you can see at each of these phases, from a storage perspective, these are different requirements. And if you look at traditional storage stacks, more than often you would end up being into storage silos. Weka, with its mixed workload characteristics, its ability to handle performance and low latency very effectively, along with the data management capabilities, is in a very unique spot to be able to cater to this kind of pipelines. And that's the reason why we are winning today. So that brings me to the new approach, which is what Weka is really formulating and spearheading here. So Weka has put together an end-to-end solution blueprint, what we're calling Weka AI. And with this solution blueprint, this is really an end-to-end solution. And we have done this primarily for two reasons. First and foremost, the personas whom we talk to, they are data scientists, chief data officers, and so on. They don't know a whole lot about infrastructure. So this kind of end-to-end blueprints make it a lot more easy for them to consume this holistic stacks. And the second reason is also it makes it easier to articulate our value proposition by not having to talk in terms of storage speeds and feeds, but in terms of AI/ML data pipelines. So here, if you can see, we are at the center stage of this as the custodians of the data set. We also work with private and public cloud vendors to be able to extend a single global namespace. But then we also work with GPU vendors, whether it be NVIDIA, whether it be HPE, and so on and so forth. We work with container and Kubernetes vendors like OpenShift or HPE Izmeral platforms. And then we work with accelerated libraries and MLOps platforms to be able to showcase an entire end-to-end solution. So we have partnership with Volohi, we have partnership with Run.ai, and a number of those uh, uh, players. And what this does is it enables us to showcase data ingest, it enables us to showcase feature engineering, hyperparameter optimization, inference, and all of that on a single platform in a single pane of glass. Okay, so that's what Weka AI is all about. This is how the actual deployment looks like for Weka. We can run in a Kubernetes environment. We provide persistent volume claims through our CSI plugin. So you can provide now statefulness to this AI/ML applications and pipelines where you need persistence across different stages of the pipeline. We also have several end-to-end reference architectures. So this was one done with HPE with 4 HPE Apollo 6500 servers. And you can see we're leveraging both inference as well as training benchmarks here. You can see we have almost highest number of images per second with 4 Apollo 6500 servers. And you can see this both for training as well as for inference. And then we have white papers which you can refer to with HP. Similarly, we also have white papers with NVIDIA. We did a reference architecture with 9 DGX, both again for training as well as inference. And you can see we can all the way go up to 160 images per second, both on Ethernet and InfiniBand. This is a Gartner criteria laid out for what kind of storage systems are ideal for an ideal AI/ML environment. And you can see other competitive approaches, whether you're using converged appliances, whether you're doing parallel file systems. And on the left-hand side, you can see the Gartner criteria. And you can see us on the right-hand side with the massively scalable parallel file system, how we are able to provide you the best of this characteristics through a software-defined mechanism. Okay. Some of the other advantages we provide is being able to reduce the epoch times. So this particular customer, we were able to reduce the epoch times all the way from 2 weeks to 4 hours, almost 80% savings for the customer, which resulted into directly top line and bottom line benefit for this customer. Another important aspect of AI or AI pipelines is this ability to provide responsible AI, and which we are able to provide very effectively by virtue of a capability what we have called snap to object. So we are able to capture the entire file namespace and tie that to a particular experimentation. So 6 months down the line, if an data scientist wants to go back and reproduce his experiment, so he's able to do that effectively, not at the compute level, but also at the data set level. And these aspects are extremely important when it comes to explainability of the experiments or the AI pipelines or the model training what you're doing. Okay. Also, we effectively are able to set up hybrid workflows and are able to provide you compliance and security, end-to-end security by virtue of our ability to provide end-to-end security, whether you're doing in-flight or at-rest security. Lots of small files. This is another hallmark when you're running a lot of AI ML applications and experimentation. You tend to create lots of small files, and our ability to support billions of files in a directory is another characteristics why we are winning in this space. GPU direct storage is a next generation of IO technology from NVIDIA. And what that means is we are able to bypass the CPU complex and the CPU memory and able to provide data directly into GPU memory. So this green arrows, what you see are the new approach, whereas the red arrows are the old approach where the data was put into CPU memory and then brought back. NVIDIA is the only software-defined storage company as part of this program, and we were able to showcase almost 163 gigabytes of performance with GPU direct storage with the latest benchmarks. We are also faster than a locally attached NVMe drive. We have a reference architecture with NVIDIA all the way scaling up to 9 DGX servers. And then also we are the highest performing vendor today for IO 500 benchmark, which primarily focus on small metadata IOs. Okay, and we did this in AWS i3 instances, which are flash based. And that kind of concludes my session. So WekaFS is actually the only vendor which is able to leverage a flash and hard disk drive very effectively to be able to provide you benefits in terms of performance and capacity. As I said, we are also available in the cloud, and we blend both on-premises as well as our cloud deployments to provide you hybrid deployments with unlimited elasticity and utility pricing. We are born in the cloud. We can work across availability zones. We are elastic, both in terms of growing the cluster as well as shrinking the cluster. We provide you enterprise capabilities, and we are extremely cost effective, even cheaper than AWS FSx cluster, which is also available, which is a competitive product available in AWS environment. So that concludes my session today. Feel free to reach out if there are any questions, comments. Thank you for attending.